Welcome to IDMC's Disaster Displacement Risk Platform. We've designed this tool so that you can explore different aspects of displacement risk. For example, you can explore displacement risk profiles for more than 200 countries. You can also explore displacement risk in one country with another, or with other countries in its region or income group. If you're interested in inter-regional comparisons or comparisons by income level, you can also visualize the data that way. Displacement risk refers to the displacement that is likely to occur in a country or a community over a specific period of time. We produced the risk metrics presented here by adapting the United Nations Global Disaster Risk Model. Whereas the UN measures and reports on the risk of disaster-related economic losses or fatalities, we've used the model to estimate the magnitude of displacement risk. Where possible, our displacement risk assessment combines two approaches. First, it incorporates disaster impacts recorded over the last several decades. Second, it complements this retrospective assessment with a model-based prospective risk assessment for more intense but less frequently occurring hazards for which the historical record is either patchy or non-existent. For these rare events, we measure risk probabilistically, as a function of hazard, exposure, and vulnerability. By combining these two approaches, we're able to generate a more comprehensive assessment of displacement risk. Displacement exceedance curves provide the most comprehensive information about displacement risk. They explain how frequently a community or a country is likely to experience a given amount of displacement. A displacement exceedance curve plots the magnitude of the displacement on the x-axis and the probability of occurrence in the return period on the two y-axes. As such, these curves represent the correlation between displacement, the displacement exceedance rate, and the return period, and they can be plotted using retrospective, prospective, or hybrid assessments. Displacement exceedance curves are plotted separately for each hazard type or category. The shape of the curve depends on the type of event considered. The curves for weather-related hazards, such as floods, storm surges, and winds associated with tropical cyclones, tend to be relatively flat. This is mainly because the return period increases proportionally with their intensity. Once a given intensity threshold is reached, the curve drops, meaning that the event's impact increases at a much lower rate than its return period. This corresponds to extremely rare and very high impact events that displace a significant proportion of the exposed population. Put another way, above a given intensity threshold, almost all of the exposed population is vulnerable to the hazard in question. Any further increase in intensity and return period beyond that point will not lead to significantly more displacement. This is the case for flooding in large river basins and severe tropical cyclones. The value at which the drop occurs depends on the proportion of the population exposed to that particular hazard. By contrast, the magnitude of displacement risk for earthquakes continues to increase. As the intensity of the earthquake grows, so does the number of people exposed to it. We've adapted existing risk metrics to make our evidence as relevant and as easy to use as possible for policy experts working on disaster risk reduction, climate change adaptation, and development. Average annual displacement refers to the number of people expected to be displaced on average each year when considering all events, both big and small, that could occur over an extended time frame. We present average annual displacement estimates in absolute terms, the anticipated number of displacements per year, and relative to population size, the number of people per 100,000 inhabitants expected to be displaced each year. Average annual displacement should be considered as an indicator of the potential magnitude of displacement, not as an exact value. When it comes to disaster-related displacement, every year is different. Displacement exceedance curves can also be used to calculate probable maximum displacement, or PMD. Probable maximum displacement represents the maximum displacement that might be expected within a given time period, over different return periods. It answers the question, what is the maximum expected displacement within a time range of X number of years? The return period is the expected average time between two events of a given intensity, calculated over long periods of time. It is usually expressed as 1 in X number of years, but the concept is often misunderstood. If an event has a 1 in 50 year return period, it does not mean that it will occur every 50 years, but that it will occur on average of every 50 years if a large enough time span is considered. For example, if we have 1,000 years of data for simulated events, we would expect to observe 20 50-year events during that 1,000 years. Now that we have an overview of basic risk metrics and concepts, let's get started. With an average annual displacement of more than 1.3 million people, China is second only to India in terms of absolute prospective displacement risk. Extensive displacement risk, shown in the upper left area of the graph, is mainly driven by low-intensity, high-frequency events like storm surges and small earthquakes. Small tsunamis, localized flooding, and high winds play a less significant role. In China, floods are usually the main trigger for major displacement events. The first episode of Yangtze River flooding in 2016 displaced nearly 2 million people. A drop in displacement exceedance curves for high winds and storm surges happens before that for earthquakes and floods because less of the population is exposed to such hazards. A larger proportion of the population is exposed and vulnerable to large-scale earthquakes and flooding, as indicated by the shape of the displacement exceedance curves for these hazards in the lower right area of the graph. Next, let's explore displacement risk in Colombia in relation to Indonesia and then other countries in Latin America. First, we adjust the tool's settings so we can look at the risk profile for Colombia, and then we add Indonesia as well. What it shows us is that in terms of displacement exceedance curves, Colombia and Indonesia have similar profiles. Both have highest risk associated with earthquakes and flooding, followed by tsunamis and then smaller hazards. And in terms of average annual displacement, Colombia has about half as much expected as Indonesia. This is due to Indonesia's much larger population, because when we look at the displacement risk taking population size into account, we see that it's twice as high in Colombia than it is in Indonesia. Now let's replace Indonesia with other countries in Latin America and see how Colombia compares. In absolute terms, Latin America and the Caribbean as a region is much higher because it's an entire region, so it only makes sense to compare the risk in relative terms. And here we see that on a per capita basis, Colombia still has higher risk than the rest of the countries in the region, mostly due to earthquakes. That brings us to the end of this demonstration. I hope you've enjoyed what you've seen and are comfortable using our interactive displacement risk platform. Over the coming months, we will be adding additional features and comparing the present risk with risk in the future by taking socioeconomic, demographic trends, and climate change impacts into consideration. If you didn't see something here you were expecting, or if you still have any questions, please don't hesitate to get in touch. Thanks again for watching, and have a great day.